we're going to look at evaluating trig functions at any angle here. This section is a little more difficult, but we're just going to kind of run through it, and then, of course, when we come back, I can work with you more on it. But maybe this will help you be able to jump in and try some of these problems anyway. Okay, so the general definition of trig functions. Let's go back and take a look at our circle. Remember how I showed you the circle. This time, we're going to draw it, okay? We have our terminal side, and then we're going to put our terminal side here. And then we're going to just simply draw our circle all the way around it. Now, what we're going to do is we will look at this from this point to this point as our radius, because the circle extends from the center to the end of the circle, but we also view this as like our hypotenuse as well. I'm going to drop a perpendicular line and form a right triangle out of it. Now, once we get a right triangle, we pretty much know what to do with it. Anything that's horizontal is our x value, and anything that is vertical would be the y value. So hopefully that helps. Now let's take a look. Sine of theta is equal to opposite y over hypotenuse radius. Okay? Then we have cosine of theta would be equal to adjacent over radius, and tan of theta would be equal to opposite y over adjacent x. And of course, x can't equal 0 here, or it would be undefined. And then we see our reciprocals. We just simply switch them around. Okay, there we go. So now we have our functions all set up here. So now let's take a look at how to solve these. In example 1, we have -4 and 3. We want it to be a point, and a point on the terminal side, and our angle is in standard position. So we want to evaluate our 6 trigonometric functions. So here we see we're at -4 on the x-axis. Okay, so we'll just say like -1, -2, -3, and then -4. Okay, and then 3 on the y. So we'll just say that this point is at 3 at -4 and 3 on the y here. So 3 or 4 and -3. The x value will be our -4. The y value will be your 3. Okay, so hopefully that makes sense. Now, of course, I'm going to need to find the radius, and the way that we can find that is by saying -4 squared plus 3 squared equals radius squared. And that's going to be 16 plus 9 equals radius squared, or 25 equals radius squared. Take our square root, and our radius squared equals, or our radius equals 5. Now we can find all 6 functions. So we can say, okay, sine of theta is equal to 3 over 5. Cosine of theta is going to be -4 over 5. And tan of theta is going to be opposite 3 over -4. And then, of course, the reciprocals, you just flip them. Now, in the case, let's just say that our 5 worked out to be square root 5, okay, which it didn't in this case. But how would we handle that? Well, don't forget, you always would have to rationalize that denominator and make it 3 square root 5 over 5. Okay, so that's how we work these type of problems here. Now, I want you to look at the top of page 867 where we're talking about the unit circle. The unit circle, we're in the key concept box, is x squared plus y squared equals 1, which has a center at 0 and 0, and a radius is 1. A radius of 1 is called a unit circle. We also have quadrantal angles in the unit circle, and that's when we take our quadrant and we divide it up into 4 sections. Now, example 2 says use the unit circle to find the 6 trigonometric functions of theta equals 270 degrees. Okay. what we're going to do here is we see here we have our unit circle, okay, and we see here that, okay, from here to here, 270 degrees, if you remember, it's down here at the bottom when we're talking about it. Also, we're going to see here at this point, our x value is at 0 and our y value is at -1, okay, because we're below the x-axis. And remember, with a unit circle, the radius is always equal to 1. Okay, so with this, what we're going to look at is sine of theta is going to be equal to y over r, which is going to be -1 over +1. Okay, and that would equal -1. Cosine of theta, which is equal to x over r, x will be 0, radius is 1, so therefore we would be equal to 0, because our radius vector will always be equal to 1, okay? And in the case here, y equals 1, so x equals 1, y equals -1, okay? Oh, excuse me, radius equals 1, x equals 0. And then tan of theta is going to be equal to y over x. What is y? -1, x is 0. Oh, guess what? It's undefined. Okay? So, that is how we use the unit circle here. And we'll go over more of these on Friday when you come in. Okay, and then the last thing that I want to look at are reference angles. Now, let theta be an angle. This is on page 868. Let theta be an angle in standard position. The reference angle for theta is an acute angle formed by the terminal side of theta and the x-axis. The relationship between theta and theta prime is shown for all non-quadrantal angles. Okay, so an example of a reference angle would be, let's just say I have a 110-degree angle here. The reference angle, we would drop a perpendicular down here and we would say, okay, our reference angle here would be 180 degrees minus 110, and it would be 70 degrees. So 110 plus 170 is 180. And you can figure reference angles in all quadrants. Another thing that you need to remember is that all functions are positive in quadrant 1. In quadrant 2, only sine and its reciprocal cosecant are positive. In quadrant 3, tan and cotan. And then in quadrant 4, cosine and secant are the only ones that are positive. Now, I know you have a good bit of work. I'm going to share the geometry law of sines videos with you. It'll be for both groups to watch because they're the same one. Just do the problems that you can do and do the best that you can do. And, you know, what you can't get, we'll go over Friday. We'll work on it. If it goes into Monday, we'll work on it too. So I just want you to read your book, watch the videos. You're more than welcome to email me, but just don't get all upset about it and think, oh my goodness, I'm going to fail. You know I'm going to be fair. You know I'm going to help you out. This is kind of a hard section to teach from a video, so just doing the best I can, and I think we'll be fine. I think you'll see that it'll work out. Okay, thank you.